Okay, guys. So chapter 9, mathematical patterns. It's all sequences and series. The sequence is a pattern of numbers separated by commas. Terms of a sequence: a sub 1, a sub 2, a sub 3, a sub 4. That's how you say that. A sub 1, a sub 2, a sub 3, a sub n minus 1, a sub n. The n is the last term, the nth term. N minus 1 is the penultimate term, the one before the last. N minus 2 is the one before that, and so on. The subscripts have nothing to do with the numeric value of your term. Because it has a subscript of 2 does not mean we take the square root or square a number. It just means it's the second term in the sequence. What subscripts let us do is use the same variable repeatedly. So A is a term. A sub 1 is the first term. A sub 2 is the second term. 1 and 2 have absolutely nothing to do with the value. It just tells me what term number it is in the sequence. So A sub 32 is the 32nd term. There are 31 before it and how many ever afterwards, depending upon how long the sequence goes for. Okay, sometimes it could be 1 term, it could be 10 terms, it could be 100 terms. The nth term is how many terms there are in there or what term number you're talking about if you don't know what term number that is. Okay, an arithmetic sequence. An arithmetic sequence is generated by a constant sum or difference. In other words, you either add or subtract the same number every time to get from one term to the next term. The sequence 1, 2, 3, 4, 5, 6, 7, 8, 9, blah, 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 is arithmetic because how do I get from one to the next? I add 1 each time. If you're adding the same number each time, it's arithmetic. Common difference, D, is the number being added or subtracted throughout the sequence. And we always say added because we subtract, we just say, oh, that's adding a negative. So if I'm going from like 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0, negative 1, negative 2, negative 3, I can keep going. I am actually adding negative 1 each time. So my difference D would be negative 1 because that's what I'm adding each time. Yes?
So a list that had an
Arithmetic.
All right, arithmetic sequence would always have a common difference.
Common difference, no matter what.
It's not an
arithmetic.
It's not an arithmetic.
We'll talk about that in a minute. So these are the first set of terms. This is the next set of notes you need to have. And I'll slide it up so you can get the little formula there. I don't know if that's
I was just thinking about that
on there or not. Okay, a geometric sequence is a sequence generated by a constant product or quotient. In other words, you are multiplying by the same number each time. 1, 2, 4, 8, 16, 32, 64 is a geometric sequence. You're multiplying by 2 each time. You can also be dividing by the same number each time. Now, when you have something where you're dividing by the same number each time, let's say 24, 12, 6, 3, 1.5, and so on, you're dividing by 2 each time. We like to think about that as multiplying by 1/2, okay? Because your common ratio, R, is the number being multiplied each time. You have to figure out what you're multiplying by each time, just like you need to figure out what you're adding each time. D is for adding or subtracting. R is for multiplying or dividing. An explicit formula is a single formula used to generate a sequence in the form that begins as A sub n. So the idea is with an explicit formula is that you can find the 10th number by plugging in 10 into the formula. You can find the 300th number by plugging in 300 into the formula. If you want to find the 1000th number, you can just plug in 1000 into the formula. You do not need the previous 999. On a recursive formula, you do need the first 999. On a recursive formula, it's a 2-part formula. First part is you are given the first number. And then you are told what do you do to that number to get the next one. And then you repeat what you did to that one to the next one. Then you repeat that to the next one. So you're told what your first number is, and then you're given a formula that tells you what to do to find the next number. So you have the first number. Let's say you're adding 2 each time. So you start with 1, and then you go to 3, and then you go to 5, and then you go to 7, and so on by adding 2 each time. Your recursive formula, your first number would be 1, and this one would be a sub n equals a sub n minus 1 plus 2, because you're adding 2 each time. To get to the 1,000th number with the recursive formula, you do need the first 999, because you can't get to the 1,000th if you don't know the one before it. Okay, you have to have the number before to get to the next number. You can't just skip somewhere in the middle of the line and see what's there. You have to go all the way down the line to get to that point. That's where what a recursive formula is. We will work with both of these in this chapter. You will use them to generate terms. You will generate these formulas as well. Okay? Excuse me. Any questions so far? Not every sequence or series is geometric or arithmetic. It is entirely possible they are neither. So, example problem number 1, determine if they're arithmetic, geometric, or neither, and find D or R if appropriate. So I always like to look, and there are ways, and I will show you shortcut ways or ways to find out for sure in a minute of how to generate the sequence, but a lot of times we just say, okay, how do I get from one to the next? How do I get from 13 to 16, 16 to 19, 19 to 22? Can I do the same thing each time to move down the line? Yeah, I can add 3 each time. So D is 3 because I'm adding 3, and this would be arithmetic. Yeah, I'm going to try to do this. This is going to show up neat on the video. Think about it. I paused the video to do that, or did not pause, I should say. So it's an arithmetic sequence. Now, you look at this next one here, 2, -6, 18, -54. If it changes sign every other term, I'm not going to get that by adding or subtracting each time. I'm not going to go from positive to negative to positive to negative to positive to negative by adding or subtracting each time. So I have to look at this one's possibly going to be a geometric sequence. So to get from 2 to -6, what am I going to multiply by? -3. To get from -6 to positive 18, can I get there by multiplying -3? Yeah, and if I add 18 to -54, I can multiply by -3. So this would be a geometric, and my R would be -3. If you change sign every other time, it's either geometric or it's neither. You're not going to be arithmetic if you're changing sign each time. Okay. This one is a little bit goofier, but I'm going to give you a hint on how to do it. Rewrite every one of these as a fraction over 2. So 3 is 6 over 2. 2 is 4 over 2. 1 is 2 over 2. And if I fill in the blanks with what's already there, 5 over 2, 3 over 2, 1 over 2. It makes it easier to see the pattern, doesn't it? If I make them fractions with common denominators, it makes it really easy to see the pattern. What's happening with my numerators? 6, 5, 4, 3, 2, 1. I'm subtracting 1 from each numerator, which means I'm actually subtracting 1/2 from each term. Does that make sense? So if you have fractions and whole numbers mixed, rewrite them all as fractions with the common denominator. If there's a pattern there, it's very easy to pick up. So this one would be arithmetic. And D would be -1/2. Now I look at the next one. 9, 10, 12, 15, 19. Okay, so first thing I'm going to do is check adding each time. To get from 9 to 10, I add 1. To get from, if I add 1 to 10, I don't get 12. It's not arithmetic. Multiply 9 to get 10, that would be 10 ninths. 10/9 times 12 is not going to get times 10. It's not going to give me 12. This one would be a neither. It's neither geometric nor arithmetic, and that happens a lot. Okay, it's actually more common to be neither than it's to be either one of those. Okay. Questions? Your turn. Do those. Okay. So I love this one here. This first one here, I love this. It's an extremely common one. All it does is change sign each time. Yeah, I have to get change sign each time. What do I do? I multiply by -1. So my R is -1, and this would be a geometric. 8, 6, 4, 2. To get from 8 to 6, from 6 to 4, 4 to 2, what do? I subtract 2 each time. So if I'm subtracting 2, which is technically adding -2, and this would be arithmetic. Um, 1.7, 2.1, 2.5, 2.9. So 17 to 21 to 25 to 29. To go from 2.1 to 2.5, that's easy to see. That's 0.4. 2.5 to 2.9, that's also 0.4. Would that work from 1.7 to 2.1? Yeah. So this would be arithmetic, and D would be 0.4. And then the next one, -6, -9, -11, -12. To go from 6 to 9, -6 to -9, I would need to subtract 3, or subtract 2, subtract 1. No, this is neither. This is a neither on this one. Okay, fairly straightforward. Okay, example problem number 2. Determine the following are arithmetic or geometric and confirm by testing pairs. There's a way you can test and find out if it's arithmetic or geometric and confirm it, and that's by either doing subtraction or doing division to see if you get the same number each time. So, for example, I look at this and I go, okay, 3 to -1, -1 to -5, -5 to -9. It looks like I'm going down 4 each time, right? So it looks like arithmetic. I'm going down 4 each time. Here's what you do. You take a number, subtract the previous number in the sequence. -1 minus 3. That gives me -4. I do that again. Take a number, subtract the previous one. -5 minus -1, I get -4. If I do that every time and get the same number, if I take a number in this sequence and subtract the number before it.
Wait, wouldn't -5 minus -1 be next? Oh.
Minus -1, right? What do? You change your subtraction to addition. If I get the same number each time by subtracting the previous, pick a number, subtract the previous one, you get the same thing each time. That would be arithmetic. And my D would be what I get when I subtract each time. So if I look at the next one, I'm changing signs every time. That's not going to be arithmetic. The best that could be is geometric. And if I look at that, it looks to me like I'm multiplying by -3. Now, to check it, instead of with arithmetic, what do? I subtract each time. For geometric, I would divide each time. Take a number, divide it by the one in front. So -9 divided by 3 gives me -3. 27 divided by -9 gives me -3. And if I take -81 and divide that by 27, what do I get? I get -3. If I divide each time, that would be geometric, and my R is what I get when I divide. So this is geometric, and R is -3. Okay. So I look at the last one. It does not appear arithmetic, but we can try it. I would need to subtract 4, and then I subtract 4 again. That doesn't work. So geometric. Let's see what I get. 8 divided by 2, 4 divided by 2. 2 divided by 2 is not 1/2, though. But I want to prove it. So 4 divided by 8 is 1/2. 2 divided by 4 is 1/2. 1/2 divided by 2 is not 1/2. Because 1/2 divided by 1 is 1/2. 1/2 divided by 2 is 1/4. So this would be a neither. Because it doesn't work arithmetic. And I can check the arithmetic if I really want to. 4 minus 8 gives me -4. 2 minus 4 gives me -2. It doesn't work for that either. So this would be a neither. Doesn't work for division, doesn't work for subtraction. This one would be neither. Okay? Questions on that? Okay, do those. The calculators might be handy on some of this stuff too. Okay, so let's take a look at these. So the first one, once again, if you're changing sign every other term, it is not going to be arithmetic. So I can just skip that possibility. Is it geometric? Do the division. -8 divided by 4 is -2. 16 divided by -8 is -2. And if I do -32 divided by 16, what do I get? I get -2. So R is -2. R equals -2 because this is geometric. Now, on the next one, I'm just going to try it. I'm going to look for arithmetic. It doesn't look geometric. I don't know for sure. But this one, trying to figure it out in my head and guess what it is kind of a pain. If I just say, all right, 9.5 minus 3.4 gives me 6.1. Do I get the same thing again? 15.6 minus 9.5. And guess what? I do get the same thing again. And if I do it again, I'm going to get the same thing again. So this one would be arithmetic. And my D is 6.1. Now the next one's a little more difficult. But if you know how to use your calculator to do fractions, it's not very hard at all. Okay, if you take 5/9 divided by 5/27, your calculators will do that for you. Your calculators, the calculators I have here, they will do fractions. They got a little fraction button on them. Okay? Now, for me, for a clue, I look right here at the end, though. To go from 5/3 to 5. To get rid of the 3 in the denominator, what do? I multiply times 3. 5/3 times 3 gives me 5. If I multiply these ones by 3, same thing happens. Your denominator reduces by a power of 3 each time. But to check it, which is what we're supposed to do, 5/9 divided by 5/27, and you get 3. And you take 5/3 divided by 5/9, and guess what? You get 3. And you use your calculators. Know how to use your tools. Calculators are tools. And what do you do when you get this? So this one would be geometric, and R equals 3. I'm multiplying by 3 each time. So my next number in the sequence would be 15. One after that would be 45, and so on. Okay. I like this because if it's a goofy one like this, or a goofy one like the last one, you can use your calculator to test it very quickly and easily. Okay. Write out the first 5 terms of each explicit formula. So let's see. Ooh, they will slide up for me. Good. Gives me some room to work. Explicit formulas. Explicit formulas mean that whatever the nth term is, let's say I want A sub 1. A sub 1 is the first term, right? N is 1. So what do? I plug in 1 into my formula. 9 times 1 is 9 plus 3 gives me 12. I want a sub 2. N is 2. I plug 2 in for n here. 2 times 9 is 18. 18 plus 3 is 21. A sub 3, same thing. 3 times 9 is 27. 27 plus 3 is 30. A sub 4. Take 4, plug it in there. 4 times 9 is 36 plus 3 is 39. And a sub 5. 5 times 9 is 45 plus 3 is 48. First 5 terms. Plug in 1, plug in 2, plug in 3, plug in 4, plug in 5. I want the 20th term, what do? I plug in 20. I want the 300th term, what do? I plug in 300. That's what you do. You just plug in whatever term number you're looking for, and that's what you get in an explicit formula. You plug in the term number and then do that. So the next one, pretty simple as well. A sub 1, put in 1. 1 times negative 2 is negative 2 minus 5 is negative 7. A sub 2, excuse me, 2 times negative 2 plus 2 times negative 2 is negative 4. Negative 4 minus 5 is negative 9. A sub 3, plug in 3. Negative 6 minus 5 is negative 11. Now, notice what's going on with these numbers here. What are they doing? They're going down by what? Notice the connection to the formula and what is changing on here. There is a connection. We're going to be writing formulas later on this week. You're going to want to see those connections. In fact, I think that's tomorrow's lessons. A sub 4, I'm going to plug in 4. Negative 12 minus, no, negative 8 minus 5 is negative 13. And a sub 5 gives me negative 15. Now the last one is the one that screws everybody up, because they don't follow order of operations. Okay? A sub 1 is negative 3, 2 to the first power. This one's not had. Everybody always gets this first one, because I get 2 to the first is 2 times negative 3 gives me negative 6. A sub 2, negative 3 times 2 squared. Order of operations, this is not 36. This is negative 12. You square the 2 first. You do your exponent before the multiplication. This one's negative 12. A sub 3, negative 3 times 2 cubed. Negative 3 times 8 is negative 24. A sub 4, negative 3 times 2 to the 4th, which is 16 times negative 3, which is negative 48. Yes, question?
So unless it says otherwise, like the first term is always 1.
Well, no, because we're asking for the first 5 terms, so I'm going A1, A2, A3, A4, A5, because then I'm only asking for the first 5. I could ask for 10 through 12, and you'd start with 10 and go through 10, 11, 12.
In the other ones, it says like...
Right, and we'll get to the other ones. These are slightly different. We'll get to that in a second. And then the 5th one, let's see, 2 to the 5th is 32 times negative 3. So that would be negative 96. So 5 equals negative 96. Running out of room. Okay, recursive formulas are slightly different. Your first term is always given to you. So if I ask you to give me the first 5 terms of the recursive formula, you better freaking get the first one right, because it's already written down on the paper for you. You already have A sub 1. To find A sub 2, to find the next term, my formula says, to find the nth term, take the one before it and add 3. So to find the next term, what do? I add 3. 2 plus 3 gives me 5. I want to find the next term. This tells me I add 3. So I get 8. A sub 4, I add 3, I get 11. A sub 5, I add 3 to that to get 14. My formula says I take the previous number and I add 3 each time. I know my first number and I add 3 each time to get the next number, the next number, the next number, the next number. I can't jump straight to the 5th number on this one like I could on the previous ones. Previous one I just plug in 5. Here I can't just plug in 5. I need to have the first 4 to get the 5th one. Or I should say I need the 4th to get the 5th one. To get the 4th, I need the 3rd. To get the 3rd, I need the 2nd. To get the 2nd, I need the 1st. That's why you're given the first number. Because you have to have a place to start. So like this one here, my first number is -3. My second number, a sub 2, what does it say to do? It says to take the number before it, multiply it times 2, then subtract 1. So I take 2 times -3 and then subtract 1 from that. Because that's what my formula tells me to do. Take the one before, times 2, and then subtract 1. -6 minus 1 gives me -7. So a sub 3, I take the one before, times 2, and then subtract 1. 2 times -7 minus 1 gives me -15, right? Yeah, -15. There's always one or two of these I screw up. Okay. A sub 4 gives me 2 times -15 minus 1 gives me -31, and so on. I'm not going to do them all here because we're running short on time. So in the next one here, so in the last one, my first term it's given as 8. Okay. How do I find the next term? 8 times -1/2, and then add 2 to that. 8 times -1/2 is -4. -4 plus 2. -1/2 times 8 plus 2 gives me -2. Okay. A sub 3, -1/2 times -2 plus 2. -1/2 times -2 is 1. 1 plus 2 gives me 3. A sub 4, -1/2 times 3 plus 2, -3/2 plus 2 is, so -1/2 plus 2 gives me 1/2. To find the 5th term, a sub 5, -1/2 times 1/2 plus 2. -1/2 times 1/2 is -1/4 plus 2. That gives me 1 3/4. I hate 1 3/4, but because it's my last number, I'm done. I'm stopping. I'm not screwing around with it anymore. They can get ugly in a hurry. Generally speaking, I don't ask for more than 5 at a time. And I don't ask for big numbers in a sequence unless it's easy to get to. Your turn. Actually, in interest of time, I'm going to leave this one to you guys to finish on your own because I've got one more example to show you. We've got like 6 minutes in class. I want to show you the last example so we can get this all done. These ones can take a while in this. Write the recursive formula. So you're basically coming up with a formula where you have the first term followed by a formula to find the next term. So you're always going to start with this. A sub 1 is 7. You always have the first term. How do I get from 7 to 9, 9 to 11, 11 to 13, 13 to 15? What am I doing each time? I'm adding 2 each time. I'm doing D and I'm adding 2 each time. So to get to the next term, I add 2 each time. So to get to the nth term, I take the nth minus 1, the one before it, and I add 2. Okay? That's what I do. I have a number I start with, and I add 2 each time. How do I get the next one? I add 2. How do I get to the next one? I add 2. How do I get to the next one? I add 2. Easy enough. So on this one, I have a sub 1 is 2. How do I get to the next term? How do I get to the next term? Multiply by negative 2. So what do I do to get to the nth term? I take negative 2 times the term before it. The nth minus 1 term. Easy enough. Let's get to this one down here. So if I rewrite these, this one's a little harder, but it's not that bad. How do I get from 4 to 1? Divide by 4. How do I get from 1 to 1/4? I divide by 4. But dividing by 4 is the same thing as multiplying by 1/4, right? I'm multiplying by 1/4 each time. 1/4 of 4 is 1. 1/4 of 1 is 1/4. 1/4 of 1/4 is 1/16 because I multiply the 4s in the denominator. So how do I get to the next term? I multiply by 1/4. So my first term is 4. And then to find the next term, what do? I multiply it times 1/4. So it's 1/4 times a sub n minus 1. To find the nth term, I take the 1 before it, n minus 1, times 1/4. Okay. Negative 15 to negative 11 to negative 7 to negative 3. What am I doing each time on this one? To get from here to here, I'm adding 4 each time. Because they're actually getting larger by 4 each time, right? So a sub 1 is negative 15. A sub n is a sub n minus 1. Sorry. And what am I doing each time? I'm adding 4. Writing recursive formulas actually isn't that hard. You have to figure out what you're doing to the previous one to get to the next one, and that's what you're doing in minus 1. Okay?